Hello guys, welcome back to Maths on African Motives, still on our mathematics grade 10, working on the algebraic expressions. In this case, we shall actually focus on the algebraic fractions, how to deal with algebraic fractions, how to simplify algebraic fractions, considering that you are supposed to leave your answer as a single fraction. So here it is to simplify the following single algebraic fractions. All right, so we are just given a single algebraic fraction and our answer is just going to remain as a single algebraic fraction, or maybe just as a normal term. Remember, we talked about these terms that we can be talking about a monomial, whereby we are given a single term like what we have in this case. In the denominator, we have a monomial, which is a single term. Yes, here on the numerator, we've got different terms. We've got a binomial. We also have a condition here where we've got a trinomial. So it can be different terms. And also in the denominator, we can have a condition like this part where we've got a binomial, where we have got a trinomial. So it's not that you are supposed to have a certain condition to answer a certain question. No, the idea is going to be the same with different types of expressions that you have. As you can see, we've got different layout of expressions, but you are going to use the same simplification in that in each and every part that you have. So let us consider question, the first question that you're given, which is x squared minus x over x. All right, I'm given a single term in the denominator here, which is a monomial term expression. So what I can simply do is to work from the numerator, because I can see that from the numerator, I've got something that is common. I've got x here, I've got x there. So meaning to say I can do my factorization because I just have two terms and there is x, which is common. So I can factor out the highest common factor in that case. Remember, I said whenever you factor out, you take out the one that is referred to as the highest common factor, the one that has got the smallest exponent. So we talked about this, that's going to take the one that has got the smallest exponent. In this case, you are comparing 2 and 1. So this is a 1 here. So we are going to factor out x to the exponent of 1, which is the smallest exponent. All right, the one that has got the smallest exponent. So that is x to the exponent of 1. If I factor out this, it means I'm going to divide x squared divided to x, which is going to give us x. Remember, x squared over x like this. You are simply subtracting, since you are dividing the powers that are the same powers, you subtract the exponents, all right? So that's 2 minus 1, which is what? Which is 1. So that is going to be x, because x to the exponent of 1 is same as what? Is same as x. All right, then we factor out, if we factor out here x divided by x, as you can see, these two terms are the same. X over x gives us a 1, just same as a over a, which gives us what? Which gives us a 1. If the two terms are the same, you get a 1 if you're dividing. All right, so that's it. This whole part here is going to be divided by the x that we have in the denominator here. All right. So considering our simplification, we can see that we have a same condition here after we have factored out everything and so forth. We have the same condition that we had here, that x over x, it gives us a 1. So it means this x and this x will cancel and we obtain a 1. So that's 1 times x minus 1. So it's going to be 1 times x. You expand the bracket, which is x. 1 times minus 1, which is minus 1. So you're going to obtain x minus 1. In that case, it was supposed to be x minus 1 over 1, which is just same as what? As x minus 1. So as you can see, guys, this is how you are supposed to simplify such typical questions, as long you factor out the one that has got the smallest exponent. All right, on number 2, we are given that 4a squared minus 8a, and everything is divided by 4a. So there is not a condition that you just have a term which is common. Also, remember, for the highest common factor, you are supposed to check also the numbers. So here, checking the numbers, I've got 4, here I've got 8. I can see that 4 is the highest common factor between 4 and 8. So I'm going to factor out 4 as the highest common factor, and between a squared and this a. Remember, we talked about x squared and x. We saw that x is going to be the one. So we are going to take a, the one that has got the smallest exponent. So that is going to be 4a. So if you factor out 4a from the top, which is the numerator in this case, what are you going to remain with? That is the question. What are we going to remain with at the end? All right, we talked about this, guys, that whenever you see a squared and a, you get an a, but here you've got 4 and 4. So it is like this, 4a squared over 4a, like this. So it means these two are the same. They will cancel each other. Then a squared divided by a, we are going to obtain a in this case. Remember, 2 minus 1 is 1, which is same as a. So our answer there is going to be a. You do the same thing to the next term that you are having. This is negative 8a divided to the term that you factored out, which is 4a. So that's minus 8a over 4a, like this. So this will cancel because they are the same. Remember, a over a gives us a 1. So you're going to cancel that, and 4, and this part cancels, we get a negative 2. All right, 4 into 8, that's a negative 2 times a 1, which gives us a negative 2. So that means here you are going to remain with a negative 2. And this whole part is being divided to 4a. So we're going to divide by 4a. So meaning to say, if we divide, we are back at the same condition that this term and this term are the same. So they can be cancelled together. You're going to cancel this, you get a 1. So that means you can multiply 1 times a, which is a, 1 times minus 2, which is minus 2. Remember, we said as long the two terms are the same, they can be cancelled to give us what? To give us a 1. So this is how you play around these typical questions. All you just need is to revise your factorization. So in case that you missed the video of factorization, make sure that you watch the video of factorization so that you'll be able to understand what we are talking about here, because it's just a continuation from the factorization. All right. So the next question, it is given as 3p squared minus 6p everything over 6p, like this, and we are asked to simplify this. All right, so back to the factorization part. On the numerator, you can see that we've got a binomial expression. So we can be able to factor out comparing 3 and 6. We're going to see that 3 as the highest common factor that we have, because 3, remember, 3 is same as 3, which is 1 into 3, which is 3. Then we've got 3, which is, so it's the same as we just have a 3 when we are dealing with a 3. Then for 6 is same as 2 times 3. So the number that is common there, we've got a 3, here we've got a 3. So meaning to say we are going to have 3, and here we've got p, which is the smallest exponent is on p. So that's our highest common factor that we take out of the bracket. So you take out the highest common factor out of the bracket. So here we are simply dividing 3p squared divided to what you factored out, which is what? 3p. So if we divide, we are going to obtain p. That's 3p squared divided by 3p. This one is going to cancel this 3 and 3, get a 1. P squared divided by p, we've got a 2, we've got a 1. So you subtract, you get a p. So 1 times p, that is going to give us a p. All right, at the end, you divide negative 6p divided to what you factored out, which is negative 3, that is positive 3p. So it's going to be negative 6p over positive 3p, like this. As you can see, p and p cancels because they are the same exponent. So 3 into negative 6, that is going to be a negative 2 if we divide negative 6 by 2. This part, you can even use your calculator on a condition that you do not understand your division part, you are failing to divide your two numbers direct. Just use your calculator to do that. you still obtain one and the same thing. That's -6 and 3. Just going to divide -6 divided by 3, which is going to give us divided. So we need a divided there. -6 divided, which is this one, by 3, which is going to give us a -2. So that's the -2 that we are seeing here. So meaning to say you are going to obtain a -2 in that case. All right. So this whole part is going to be divided to 6p. So what is going to happen in that case if we divide this whole part to 6p? As we can see, we're back to the condition that the p here and the p will cancel because they are the same. A over a gives us a 1. So that's we've got a 1. But what's going to happen between 3 and 6? All right, if we divide here 3 into 3, that is a 1. All right, if you divide 3 divided by 3, that's a 1. 6 divided by 3, that is a 2. So that means you are going to remain with a number in the denominator. So this is going to remain as p minus 2. From this part, you're going to have p minus 2 in the numerator because you multiply by 1, that is 1 times p, which is p, 1 times minus 2, which is minus 2. But everything is going to be divided by 2 that we have here, all right? So that means we are going to have it as a single fraction as p over 2, p minus 2 over 2. Some can divide back to say this p minus 2 over 2 like this. It means p over 2 minus 2 over 2, which is actually one and the same thing that we are talking about, which is going to be p over 2 minus 1. Or you can just have it like that, which is one and the same thing. All right, so that is how our questions might be given, as you can see. So like I said, you just have to be careful the way you simplify your questions and so forth. So it is the same scenario that we have even on question number 4, even though we are having 8 with a squared, but we have the same condition that the numerator can be factorized. All right, so we can factorize our numerator, which is we are given in this case that is 4m squared plus 4m everything over 4m to the exponent of 2. So like I said, we can check between the numerator if we've got a common term. So we have a common term, 4 and 4. That is, we're just going to take that 4 and m squared, which is m to the exponent of 2. The highest exponent is at 2 and the smallest exponent is at 1. So you take the smallest exponent, which is m. So let's see what we are going to have if we do this. It means you are going to divide this and this, all right, which means you are going to have 4m squared divided to 4m. This one and this one cancels, they're the same, all right, m squared and m, this one is going to give us m to the exponent of 1, which is same as what? Which is the same as m, all right, so that is the same as the m that we have. Then we have got 4m divided to the 4m. So as you can see, these are the same. And we said if the numbers are the same and you cancel, you get a 1. So that is going to be a positive 1 in that case. All right. So let us see what you're going to have if we divide everything to this 4m squared in the denominator. All right. So this is the case here. You can cancel the 4 and the 4, which is fine. You get your 1, right? Because they're the same. But here, this is m, this is m squared. And this m that we have is in the numerator, and this m squared is in the denominator. All right, take a condition, guys. We know that this simply means there are 2 of the m that we have. Just take a closer look. Like we've got m to the exponent of 2. It simply means we've got 2 things like m times m. So meaning to say we are going to cancel 1 of the m and we remain with 1. There are 2 of them. So 1 is going to be cancelled to this m. You remain with 1m. So that is the condition that you simply have. If you've got x over x to the exponent of 3, you know that I have got 1x. Here, there are 3 of them. So if I cancel, I'm going to remain with 1 over here. There were 3 x's here. But now I have cancelled with 1 of this x. How many are going to remain? 2 will remain. So it will be 1 over x squared. So you can take that Not to say we're going to have it like x times x times x like that, where you cancel this and this, you remain with 1, and you have x times x, which is x squared. You can, it's something that you can just take into closer look and ask yourself to say, I have 1, I have cancelled to 3. How many are remaining? So here we are going to remain with just m. So therefore, we are going to have m plus 1, everything over m. Yes, like I said, you can try to separate your fractions, which is fine, but here we can just leave our answer as a single fraction like that. All right, we have a same scenario, but now considering a condition whereby we are given a division. We shall actually talk about this as a full part, or in detail. We shall talk about this between the division and the multiplication, as we understand that when we are working with fractions, it's very difficult for us to work with a division. So whenever you are dealing with a division like this, remember that statement, that it's very, very difficult for you to divide direct your numbers. What I'm saying is that it's difficult for you to divide as it is. So what do? You introduce a multiplication in place of this division, meaning to say you are going to be left with a cubed minus a squared over 4. The moment you introduce the multiplication here like this, it was a division before, now it's a multiplication. The moment you do that, you tip the second fraction. You just interchange your second fraction. That means 8 is going to be written on top. A squared, we are going to write it down in the denominator. So that is what we are now having at the end, which we know that we can simplify this by dividing. As long there's a common term between the numerator and the denominator, we know that it can be cancelled as long we have a condition like this, that if the terms are same between the numerator and the denominator, you can reduce those terms. So you can divide 4 divided by 4, that is a 1. 8 divided by 4, that is a 2, right? You divide 8 divided by 4, you get a 2. So meaning to say this 2 is going to multiply this part that we have here. So it's going to be 2 into the bracket of a cubed minus a squared like this, all over 1 times a squared, which is going to be a squared. That is a to the exponent of 2, a to the exponent of 2. So the question is that if I'm given this, or if I am having this now, how am I going to simplify further? All right, take note here, I've got a, here I also have a. So it means I can proceed with my factorization, just like the previous case that I had. So I'm going to factor out the one that has got the smallest exponent, which is a squared. Remember that 2 is already out of your brackets. This one, it was already there. The term that we are focusing on is this one that we just factored out now. So it is the one that we are going to use to divide back into this bracket, because we factored out a squared. So we are going to divide a to the exponent of 3 divided by a squared, not by 2, because 2 was already out of the bracket. All right. So we are going to divide, you subtract 3 minus 2, which is 1. So that's a to the exponent of 1, which is what? Which is a. So meaning to say we are going to remain with a minus, you move on to this part of a squared divided to a squared. So as you can see, they are the same, a squared over a squared. I say as long the exponents are the same and these two terms are also the same, you get a 1. So meaning to say here we are going to get a 1, all right? Everything over a to the exponent of 2. So we are going to have our answer with the denominator having a to the exponent of 2. But we can see that this a to the exponent of 2 and this a to the exponent of 2, they are the same, just like what we had here. So we are going to get what? A 1 if we divide. So meaning to say if we divide these 2, we are going to get a 1. So that's 2 times 1, which is 2. This 2 here times 1, which is 2 into a minus 1 like this. So this is what we can have in simplest form from what we had. So guys, you have to be careful how you play around with your algebraic expressions, which are the algebraic fractions. So like I said, there are so many questions. All you just need is to know your factorization, dig deep, your factorization, make sure that you factorize all the terms. So this is what we have. We can answer so many questions. There are so many questions to consider there. So I'm not going to work out like everything. Let us just see maybe question 7 where we've got a condition of so many terms that we have in the numerator that is a trinomial and a binomial in that case. All right, so we've got x squared minus 5x plus 6, everything over 2x minus 6. So this is being divided to 2x minus 6 like that. All right, so be careful on how you are going to simplify this fraction that we see here, because if we consider that this is a trinomial and this is a binomial, on a trinomial, what I see is that the number that is affecting our x squared in this case, which is the coefficient of x squared, is a 1. Remember, guys, you are supposed to factorize. The same thing you are supposed to do in the denominator, you are supposed to also factorize and then simplify. So how are you going to factorize in this case the numerator where we are given a trinomial expression? So what you're going to see is that, remember I said if the number here is a 1, you have a direct factorization. As long the number affecting x squared is a 1, you just have your two brackets direct, all right, where one is going to be x, the other one is going to be x, so that you obtain this x squared. Then also I said what you're going to do is you are going to consider the constant. So like I said, please guys, make sure that you watch the introduction. All right, you consider your constant, which is plus 6, which is our constant, in this case plus 6. What are the factors of plus 6? But these factors of plus 6 should give us a negative 5. So we need two numbers that we are going to multiply. And if we multiply these two numbers, they must add up to minus 5. So the two numbers, you can try, like I said, this one is a trial and error. You can try 6 and 1. You can try 2 and negative 3. But as you can see on these numbers, the possibility of getting a 5 is in 2 and 3. But this is negative 5, not a positive 5. So what I can do is to simply put a negative on both numbers so that the product gives us a positive 6. So I'm going to use a negative here, a negative here, a negative here, and a negative here, so that if I multiply a negative to a negative, I obtain a positive. Remember, the condition is that if you multiply the two numbers, you must get a positive 6. But if you add the numbers, you must get a negative 5. So you're going to try to add these numbers and see where you are going to obtain what? A negative 5 in that case. So you can try even to use your calculator if you do not understand negative 6 plus negative 1 like this, which is going to give us a negative 7. So here, this one cannot give us negative 5. So we put it away. We move on to another one that is negative 2 plus negative 3 in that case like this, which is going to give us a negative 5. Negative 5, which is exactly the number that we want here, a negative 5. So these are the two numbers that you're going to take. If you add them, they will give you a negative 5. But remember, we said the first thing, if you multiply them, they must give you a positive 6. If you multiply them first, that is the first thing. You test from multiplication, then you move to addition. If you add, you must get negative 5. All right, so you saw that it's going to be negative 2 and a negative 3 in that case. All right. Then we move on to the denominator in this case. Again, like I said, you need to factorize this part. All right. So how are we going to factorize this part? This one is a binomial expression, which is straightforward, just like the other binomial expressions that we have been checking around here, just like this part of a cubed minus a squared, x squared, 3p squared minus 6p. Those were direct expressions that you just have to factor out a common term. And the common term between 2 and 6 is a 2, right? X is not common here. So you're going to take 2 as your highest common factor, then we can divide. So it's 2x divided to this 2, right? So if you divide 2x and 2, 2 and 2 will cancel, you get an x. So that's 1 times x, which is x, all right? Minus 6 divided to 2, that's a minus 3, right? So that means we can simplify further. In this case, we can see that there's something happening between the brackets. The bracket here and the bracket here are the same. So the part that I was saying of a minus a giving us a 1, as long the two are the same, it can be a bracket, it can be an exponent, x to the exponent of 7 over x to the exponent of 7. I simply cancel and get a 1. Whether they are brackets, so this bracket can be cancelled to this bracket and obtain a 1. So that's 1 times x, which is x, 1 times minus 2, which is minus 2, and everything over 2, just like that. So this is how you play around with your simplification. All you just need is to make sure that you are working with your algebraic expressions properly. Do factorize your algebraic expressions properly, guys, and you actually understand what we are talking about. So like I said, I'm not going to answer like everything here. I want us to consider all these questions, do factorize them, and where there's a question which is still giving us a challenge, let me know so that we can revise them together. That can be very, very helpful if we do revise those questions together so that you can properly see how do you answer those typical questions and so forth. All right, let us check what we have on question number 10, because we've got a different scenario of a factorization there. We are given on question number 10 that is 27 p to the exponent of 3 minus 8 like this over that is 27 p to the exponent of 2 plus 18 p plus 12 like this. This is what we're given. All right. So if we are to consider this to say we are supposed to be simplifying where you are supposed to factorize the numerator and you also factorize your denominator in that case, you will see that even though the type of expression there that I'm supposed to factorize, this one it's referred to as a difference of 2 cubes. We've got a condition of difference of 2 squares. But when there are 2 cubes, we can have a sum and we also have a difference. All right, what are cubes? These are numbers that we can direct a whole number to the exponent of 3. 3 to the exponent of 3, that is equal to 27. 3 times 3 times 3. Multiply 3 3 times. 3 times 3 times 3. 3 times 3, which is 9. Then 9 times 3, this one, which is 27. So that means 27 is a cube. All right? We're having a cube because it's being raised, a number has been raised to the exponent of 3. So this type of a number is a cube. Maybe I'm talking about 2 to the exponent of 3, which is 2 times 2 times 2, 3 times. 3 times, which is the exponent. 2 times 2, which is 4. 4 times 2, which is 8. So you get an 8. So these are the numbers, the types of numbers that we are referring as cubes. Maybe we have got 5 to the exponent of 3, which is 5 times 5 times 5 like that. Whereby we've got 5 times 5, which is 25. Then 25 times 5 is going to give you 125. So all these, they are perfect cubes. But we are now saying it can be a sum or a difference of these cubes. We can have a sum of the cubes, or we can have a difference of the cubes. So the question is, how do I factorize? In this case, we are given a difference because 27, like we can see, is the same as 3 to the exponent of 3. All right? 8 is the same as 2 to the exponent of 2 to the exponent of 3. So the question is that if you are to consider your factorization, how are you going to have this? All right, so let us consider in terms of A and B. I'm just going to write this in terms of A and B. So it follows that A cubed plus B to the exponent of 3 like that. That is A to the exponent of 3 plus B to the exponent of 3, which is a sum of 2 cubes. Remember, we talked about this in our introduction. All right, we talked about this in our introduction that it is going to give us A plus B into the bracket of A squared minus AB plus B squared. All right. This is something that is very, very important to consider, guys. Very, very important. We talked about this, but just a recap. These are the numbers that you can write like to the exponent of 3. Then 1 is going to be A plus B, which is this number as it is A plus B. All right. Then the other part, A squared, the same A, but this time being squared, minus the product of A and B plus the square of what? The square of B. So if you are to consider that here we have got 27, which we said is same as 3 to the exponent of 3. So this is same as 3p, everything being raised to the exponent of 3, because as you can see, p is also being raised to the exponent of 3. So I can use this as the exponent of 3 affecting both, because it's like this, guys. It's 3 to the exponent of 3 like this for 27, p to the exponent of 3. Remember, from our laws of exponents, if the exponent is the same, you can take it out of these two. So it's going to be 3p to the exponent of 3, which is this one that we are seeing here. All right. So we move on to negative 8, which is the same. This part of 8, we said is same as 2 to the exponent of 3. So it's same as we have minus 2 to the exponent of 3. So if we are to check properly on this question that we are now having, we can see that here 3p squared is the part that is represented. This part of 3p is your A, which is this part. So it's A cubed. All right. Then we've got 2 cubed in this case representing B. All right. So if this one is a minus, this one is going to be a minus, and this one is going to be a plus. This is what you just have to interchange. If we have a minus, this will be a minus, and this will be a plus. So meaning to say, since we have a minus here, we are going to use a minus as it is. All right, here is going to be A minus B. Here is going to be A squared plus AB plus B squared. So that is the idea that you're going to just have. So meaning to say, at the end, we are going to have something of this nature. This was going to give us A minus B, which I said this is your A, this is your B. So A minus B is just the difference of these 3p minus 2. So it's going to be 3p minus 2 in this case, into A squared, which is this part of 3p, but being squared. So it was supposed to be like this, 3p like this squared. But guys, we know that 3p squared can be simplified. As we can see, 3 and p are being affected by the exponent of 2. So it simply means 3 is going to be raised to the exponent of 2. Also, p is going to be affected to the exponent of 2. So we are now back 3 to the exponent of 2, which is 9 p squared. So we are going to obtain 9p squared. All right, we move on to the other part, which is plus. So you're going to, like I said, this one, if it is a minus, it is going to be a minus here, then it's going to be a plus. So it's A squared plus AB. All right, so this is going to be a plus. Then we have got a, b in this case. All right, that is our a, which is 3p, our b, which is a 2. So you multiply ab means a times b. So 3p times 2, which is going to give us a 6p. So that means we are going to have plus 6p in that manner. All right, sorry for that, guys. Sorry for this. Then we move on to the other part, which is plus b squared, which is the last term. B, which is represented by 2. So that is 2 squared, and 2 squared is 4, which is 2 times 2. So that means we are going to add a 4 here. So this is how you are supposed to have this at the end if you were to factorize properly this expression that we are seeing here, right, on this question. So meaning to say here, we are gonna just gonna take this as it is. All right, so this is equal to we factorize this whole part, we got this answer here, this whole answer here, which is 3p minus 2, like this, into the bracket of 9p squared plus 6p plus 4. In that case, you're going to just take this bracket as it is. That means you have factorized the cubic expression, which is the sum and the difference of two cubes. You can factorize them that way. But now let us consider to say at this stage, what is going to happen now? All right, can we factorize this direct? All right, is there anything common? Remember the golden rule of our factorization. If we have a common term, we are supposed to factor out the common term between 27, between 18, between 12. Do we have a common term between these numbers that we refer to as the highest common factor? So we are going to see that between these two numbers, 3 is the highest common factor. Remember, 27, guys, is same as 3. You divide by 3, that's going to be 9. By 3, that's going to be 3. You divide by 3, you get a 1. All right. You move on to 18. You divide by the smallest number, which is 2. 18 divided by 2, which is 9. Divide by 3, which is 3. Divide by 3, you get a 1. All right. You move on to 12. In that case, you do the same thing. By 2, that's going to be a 6. By 2, that's a 3. By 3, that's a 1. So we can properly see that the highest common factor, considering the numbers that are common throughout, is going to be a 3 that is common. We've got a 3 here, we've got a 3 here, we've got a 3 here. That is the only number that can be common between these three numbers, which is what? Which is 3. So meaning to say, our highest common factor before we do anything is what? Is a 3. So you're going to factor out a 3. If you factor out a 3, which is your highest common factor, what are you going to do? You have to divide back. So it's 27 divided to this 3, which is going to give us a 9. So that's 9. But remember, there is a p squared there. All right. Plus 18 divided by 3, which is going to give us a 6, but we've got p. All right, 12 divided by 3, this one is going to give us a 4. All right, so as we can see, that miracle that we've been hoping for has just occurred, because we can see that these two are the same. This part of the numerator, this bracket, and this bracket are the same. And I said you can cancel if everything that you have inside the bracket is the same as in the other bracket, you can cancel to obtain what? A 1. So that means you're left with a 1. So that's 1 times 3p, which is 3p minus 1 times minus 2. That's a minus 2 there. All right. Then here we're just left with a 3 that is in the denominator. We are just left with a 3. So you see, guys, revise back your factorization. We talked about all these types of expressions in our factorization. So let us just go back and revise. Like I said, if there are questions that you still feel like they have challenges to attempt on this exercise, let me know so that we can work them together as we are revising. You just have to be careful in your revisions. We talked about different types of expressions, even this one, where we can see that. Let us just have this one as the last question, where we are given here you are supposed to do your factorization properly again, because we can see that there is something that is common. Here we've got x to the exponent of 2 into x plus 2 minus 4 into x plus 2 into x plus 2 to the exponent of 2. But if we are to consider this, we can see that we've got something that is very common in the numerator in that case, which is x plus 2. The bracket of x plus 2 is the same. So we can factor it out. That is the common bracket of x plus 2. And what do we remain with if we factor out this common bracket of x plus 2? All right, we are going to divide it x plus 2 and this x plus 2. So it will cancel and you remain with x squared. So your answer there, you are going to remain with x squared minus, as you can see, these two are the same. They will cancel each other. You remain with a negative 4 in that case. All right, so this is what you're going to have, everything over x plus 2 to the exponent of 2. So as we can see, yes, we can cancel because this bracket and this bracket are the same. Or you can just leave it like that, because here, if you consider this bracket here, we can see that it's not just a normal binomial that we are used to. It's not just a normal binomial where we've got maybe x minus 3 or maybe 6x minus 3. No, this one is a special type of an expression, because we can see that this is a perfect square and also 4 is a perfect square. So we are having a condition of what? The difference of two squares. So we're having the condition of the difference of what? Of two squares. And we know that from our difference of two squares, it follows that if we are given a squared minus b squared like this, it is going to give us a minus b into a plus b. All right, so you're going to have a minus b into a plus b. That's a difference of two squares, which simply indicates the square root of this and the square root of this in this bracket. You're going to have the square roots of these two terms. So that means here, I was just going to write this bracket as it is because it's not part of my difference of two squares. The difference of two squares is the one that is in this bracket. So that's where you are supposed to factorize your difference of two squares. You have your two brackets. As we know from our difference of two squares, we're going to have two brackets where we determine the square root of this term, which is the square root of x squared. Remember, the square root of x squared simply means x squared you divide, if it is a square root, you divide by 2. So that is going to give us x. So if we divide this, the square root of x squared is x, we're going to have x and also x in this bracket. All right, as we can see, it's going to be a minus b, a plus b. Another bracket must subtract, another bracket must add the square root of this number, which is the square root of 4. And we know that the square root of 4 is 2. So another one is going to subtract, another one is going to add. And all this part is being affected by x plus 2 squared. Squared means there are two brackets. There is x plus 2 multiplied to x plus 2. That is what it means when you are given a squared like that. There are two brackets that you are having. If it is to the exponent of 3, there are 3 brackets. To the exponent of 4, and so on. There are 4 brackets and so on and so on. So at this stage now, we are back to condition that I explained before, that you can divide or cancel out as long you've got common terms between the numerator and the denominator. We've got x plus 2 here and x plus 2. So this will cancel. We get a 1. We've got x plus 2 here and x plus 2. This cancels. We get a 1. So meaning to say we're going to be left with 1 times 1, which is 1. And you multiply it to x, 1 times x, which is x, 1 times minus 2, which is minus 2. So our answer is just going to be x minus 2 at the end without anything, because as we can see, our brackets are the same. So these brackets, they will do cancel whenever you're given a condition that the brackets are the same. They will do cancel. So these are the typical questions that you're going to be asked in your syllabus. On the simplification of algebraic fractions. That is the first part. Like I said, we shall have an extension of these algebraic fractions going up to the addition and subtraction of algebraic fractions. So there are so many things that you need to know. So make sure that you subscribe to this channel so that you won't miss any of the classes that we are going to have at the end.